Hello everyone. In previous lectures, we have studied Z transform and the inverse Z transform. In this lecture, we will study Z domain analysis for LTI system response. We have known the relationship between system transfer function and YZS of Z. In time domain, we can get the relationship YZS of K and input signal. And in Z domain, we can get the relationship between YZS of Z and X of Z. In time domain, we use differential equation to get the response. In Z domain, we use this differential equation to get its equation in Z domain. Then we solve this equation to get the response Y of Z in Z domain. Then by the inversion of unilateral Z transform to find its response in time domain. For example, we have known the differential equation for a causal LTI system, and we have known its initial conditions and the input signal. Determine its response. According to the time shift property of unilateral Z transform, we can convert the difference equation into Z domain equation. Reorganize this equation, we can get the result. This fraction corresponds to YZI of Z. This fraction corresponds to YZS of Z. And we can get the system transfer function H of Z equals this fraction. Because the system is a causal system, so its region of convergence should be in this form. The number is the largest magnitude of pools. According to this equation, we can get YZS of Z. By the partial fraction expansion, we can get this equation. By the inversion of unilateral Z transform, we can get the zero state response for the system. From YZI of Z, we can get the system zero input response. So we can get the complete response Y of K equals YZS of K plus YZI of K. Here is another example. We have known the difference equation for the causal LTI system, and we have known its input signal and initial conditions. Determine the transfer function and the impulse response. Zero input response, zero state response, and the structure diagram for the system. As the system is causal, we can use unilateral Z transform. By the time shift property of unilateral Z transform, we can get this equation. This fraction corresponding to the H of Z. According to the H of Z, we can find its pools and zeros. This is pool zero plot. 2 zeros, 2 pools. according to the system transfer function, we can get its impulse response h of k. As the region of convergence of the system transfer function does not include the unit circle in Z plane, the causal LTI system is unstable. According to the initial conditions, we can get yzi of z by the partial fraction expansion. We can get the zero input response of the system. According to yzs of z, we can get its zero state response of the system. We write h of z in the form z sup minus 1. We can get the structure diagram. This number corresponding to its numerator coefficients. These numbers correspond to its denominator coefficients. Here is another example. We have now the zero state response for the causal LTI system, and the input signal determine the transfer function and its pole zero plot. The difference equation, system impulse response, and the system stability. According to the zero state response and the input signal, we can get h of z. There are two zeros and two poles. According to this system transfer function, h of z, we can get its difference equation. According to the h of z, we can find its impulse response h of k. The causal system is stable because all the poles for the causal LTI system are located inside the unit circle in Z plane. In this lecture, we have studied Z domain analysis for LTI system response. That's all for today. See you later.